Hi, today we are going to do some energy chain construction. What does this mean? That means we will trace the path of energy and we will look at energy from various avatars. And from there we will also learn how in each form energy gets transferred from one place to other. So we will learn this by this small video today. Okay, so this is brought to you by Real Learning Center where we focus on real learning. Okay, so let's start with an extremely simple question. Okay, the question is, what powers our car? Okay, the car easily moves and we know what powers our car. You know the answer. The first answer is very easy. Okay, what powers our car is, we know very well that it is petrol or diesel. We call it gas also. Okay, it powers our car. So the next natural question is, where did petrol come from? Where did petrol come from? So the answer to that question, most people can answer, is actually it is from the decomposed dead animals from long ago. So it's called pre-Cambrian era, even before the dinosaur era. So there were some animals and plants which actually dead and decayed and went into the earth. Inside that, and a lot of pressure, and it created what we so call today fossil fuels. So it came from there. So the next natural question that we ask is, yes, where did these animals get energy from? From where did they get energy from? So these animals, Precambrian animals, where did they get energy from? So the answer to that question is, it came from eating other animals or plants. So ultimately it can be traced to some plants which is in the food chain, the last in the food chain. So it comes from plants. Now suddenly we ask a question, okay, where is the energy coming for plants? From where are they getting energy? So this answer most children actually know. The energy to plants comes from sun. They got energy from where? They got it from sun. So we now can very clearly say that our car is actually powered by sun. Sun is actually powering our car. So see, we are already using solar energy. It is just that it has gone through a long chain of energy transformations from one state to the other. So we are not going to stop here. We are going to ask questions, more questions. Okay, now we are saying that sun actually is powering it. But we have this small doubt, which is, but how is this energy stored in petrol or animals or plants? So how can you store energy? So if it is a battery, we understand that we can store energy. But animals and plants, do they have battery inside? How do we store energy? Or it's not like storing water into something. So how is energy stored? So the answer to that question, we have to again try to understand how energy gets stored. Okay, let's start from a very simple scenario. You take, for example, any animal, okay, or a plant. I am choosing an animal here. You take one animal, okay, and in the animal, you take one small part. That small part, one dot you take, and now you basically zoom that dot. Okay, you zoom the dot fully, and once you zoom the dot, and you can actually look at that using microscopes, a very strong microscope. You can see huge, big organic molecules. So they are made up of atoms connected together through what we call chemical bonds. So these chemical bonds actually store energy. The energy is stored in the chemical bonds. There are various kinds of bonds. So their bonds are classified into like single bond, double bond, triple bond, like that. So what are these chemical bonds, and how do they store energy? We need to know that, because chemical bonds are not like a small tubes where you fill something. They are just shown as those tubes. It is just force of attraction and repulsion balanced together into those bonds. So how do they store energy into chemical bonds? So to know that, we need to understand certain other form of energies. Chemical bonds are like spring arrangements. So you see, in a spring arrangement, let us say I hold a spring tight, pull it like this, and I'm holding it like this. Okay. So now how is, I can say now that the energy is stored in the spring. How is the energy stored in the spring? Why is it stored? So, in the spring, energy is stored in a way of basically opposing a certain mechanical force. There is a mechanical force. If I do not hold it like this, if I leave it, that force will pull it. Okay, there is a mechanical force. Against that force, against that mechanical force, I am holding it. And that kind of an arrangement has created some energy that is stored in the springs. We say it is stored in the spring. Okay. So in the case of a chemical bond, there are no mechanical springs, etc. What do we have there? We have electrical forces. The forces between electrons and nucleus. The force between electrons of one atom and the nucleus of the other atom, and electron of one atom and the nucleus of the same atom, two nucleuses opposing each other. Like that, multiple forces are there. All these forces are acting together to create a certain arrangement. And that arrangement basically is very delicately balanced, and that we call a chemical bond. So chemical bond is simply nothing but the arrangement of this force of attraction and repulsion. Then what happens? In the case of a spring, if you release the spring, what happens when you release the spring? Suddenly the energy stored in that will come into action, and the kinetic energy releases. So it is the ball moved away. Okay. Similarly, in the case of chemical bonds, if you distract or if you break the chemical bond, the energy will be released. So that is how energy is stored in a chemical bond. And you can see very clearly that if you take, for example, this one molecule, this is one of the molecules in the big molecule. It's called 2,2,4-trimethyl pentane. This is one of the ingredients of petrol. Okay. So there are, you can see the connections between carbon atoms and hydrogen atoms and all. So those bonds actually are storing energy. Okay, they are held in some balance between the forces. And now, let us say I take such a petrol and fill it into your car. When I fill the petrol into the car, actually, in the car, what happens is from the petrol tank, finally it goes into the engine. An engine is nothing but basically a cylinder and a piston that is going up and down, you can see. Okay. So when the petrol gets into that, it comes through an inlet valve and goes through an outlet valve. Okay. So when petrol comes inside as a gas, it is basically given as a gas there, and once it comes inside, so there is a spark plug that you can see, which now it is basically lighting up. Okay, spark plug lights up the petrol, and once it lights up, the bonds inside those trimethyl pentane, they break. When they break, there is a huge amount of movement. The energy gets released. The pressure of the gas increases inside, and when it increases inside, it pushes the piston downwards, and then again piston goes back because of the other rotation. So the piston going up and coming is nothing but the movement of the engine. This is called an internal combustion engine. It's a 4-stroke engine. Okay, so when that takes round and round, and that is connected to finally the wheels, and hence the car moves. So that is how the bonds that are in the petrol are broken. Okay. So now, so that is all fine. The next question that comes is, now who stores energy into these bonds? Who stored it in these bonds, the energy? So for that question, so you start digging out the answer. So you see, plants actually have this ability. They build bigger molecules using smaller molecules using light. So you can see the plant and the light falling on that. So it has something called as chlorophyll inside the leaves. And what they do, they take smaller molecules like water. Water, you can see, is just one oxygen and 2 hydrogen. and carbon dioxide is just one carbon and two oxygen. These are small, small molecules. And many such smaller molecules it takes and builds a bigger molecule called as glucose. Okay. So, or it could be protein. So, it builds bigger molecules. So, those bigger molecules actually store energy, sun's energy in their bonds. You can see those bonds actually store the energy. Store the energy means simply what? Force of attraction and repulsion, balancing and holding out. Okay. And if you release that, it will actually release energy. So that is how they store energy, the glucose. Now what happens once they are there in the plant, okay, they don't stop there. Now that plant is basically eaten up by animals. Animals consume plants. Okay. So they contain molecules like glucose and proteins. And glucose and proteins are eaten up by animals. Okay. Once animals eat that, they grow. And animals are all built using proteins. Our body is all like, our brick of our body is like protein. They are built using proteins. Animal's body contains proteins. Now, those proteins, what happens when the animals die and decay? Okay. When animals die and decay, and gradually those proteins are getting converted under the earth pressure as things like trimethyl pentane and petrol, those kind of things. And those petrol, when you put it, and that petrol when you put into your car will start moving. Okay? And car will start moving. So, now do you agree that actually sun powers our car? So we now completely understood the concept of from where the energy started, how it is stored and how it comes up to the car. So we asked a very simple question like how is our car powered, and we got a very long answer, but we learnt a lot. Okay. So but still our quest and our question in our mind is not yet completely answered. So that's all fine, but I want to trace the energy chain further. So where is sun getting energy from? Who gives energy to sun? So that is an interesting question. The sun actually is such a hard ball, huge one, which is inside, we call as a core of the sun. Inside the core of the sun, there is a lot of activities are going on. What are those activities? So you can see that there is a lot of movement of molecules. They are not just staying there, they are all hydrogen atoms. So those hydrogen atoms are actually bouncing with each other very hard, and when they come in contact with each other, they actually combine together to form helium atoms. And that process, combining combining hydrogen atoms to make a helium atom, that process we call as nuclear fusion. Okay, this is called nuclear fusion. Inside the sun's core, this nuclear fusion is happening. So this nuclear fusion generates a lot of energy, and it comes out as radiation, and it will reach us, the earth, and everywhere else. So this kind of a combination of hydrogen atoms to form helium atom is called nuclear fusion, and it's also called with another name. It's a huge explosion generally when it happens. It's a chain reaction kind of a thing. Thermonuclear reaction is what they call. And this is basically called as a hydrogen bomb. Okay, if we create two hydrogen atoms and helium atom using two hydrogen atoms and make them more and more, it actually is like a hydrogen. It is called a hydrogen bomb. Okay, so finally, if you ask a question, so now just a little bit detail into how helium plus energy gets released from hydrogen. Okay, that we will see. There are actually 6 hydrogen atoms if you take, and 6 hydrogen atoms. Out of that, 2 of them combine together to form basically what we call deuterium. D is deuterium, and deuterium mixes again with hydrogen and forms something called as helium-3. Okay, it's an isotope of helium, and these 2 helium isotopes actually join again together to call beryllium-6. It is a isotope of beryllium, and then then spontaneously splits into 1 helium and 2 hydrogen and a lot of energy, and this solar energy actually reaches us. So Now do you agree that the hydrogen bomb actually powers our car? So first we said petrol powered our car, then we said sun powered our car. Now we are saying hydrogen bomb actually powers our car. So that is how far we reached in our energy chain. Okay. So let's ask a second question and just get a little bit of practice on this. Who makes birds fly? That is our second question. So birds, when they fly, who makes it fly? So I think now you can answer this question. So the birds fly because of the energy in their muscles. The muscles have stored energy, so it flies. So how does it get energy? How do they get energy? So from the food, of course. Now that food can also finally be traced to plants. And once it goes to plants, you know how to answer the question. So now where are the plants getting energy from? The plants get energy from what we call photosynthesis, which we just now talked about, which is basically combining smaller molecules and give rise to bigger molecules using sun's energy. It's called photosynthesis. So we saw that. So it gets energy from sun. So the answer is sun makes birds fly. Sun makes birds fly. So quite interesting, isn't it? So now let's ask a third question. Okay, we will not go a little further into the second question. Now go into the third question. The third question is, who lights up our home during days and during nights? So I think the days are somewhat easier to answer. Sun actually lights up our light during days. So sunlight enters, either diffuse light or direct light enters our house. So we have a lot of light during day. So what about night? During night it is electricity. Okay, electricity lights up our home. So, but where are we getting this electricity from? That is the question. Okay, when I asked this question to a boy, so he said electricity comes from wires. Now that is perfectly right. It comes from the wires. Okay, so but where are these wires coming from? Electricity comes to our house from wires. So where are these wires coming from? The electrical wires are coming from electrical power station. So we have many types of power station. One of them is a hydroelectric power, where water moves a turbine. Okay, you can see the water is flowing and it is moving a turbine. And the turbine is connected to an electrical dynamo or a generator. Based on Faraday's principles, it converts mechanical energy into electrical energy. And that electrical energy is going into the lines and it is coming to your home. Or sometimes it is the thermal power plant which gives you the energy. What happens in a thermal power plant? In a thermal power plant, the water is heated using coal. Coal heats up the water. And then water gets converted into steam. And that steam turns the steam engine. And the steam engine in turn turns the electrical dynamo or the generator. Okay, as based on Faraday's principle, again, it generates electricity and that electricity comes to your home. Or it could be sometimes the wind turbines. That's a new mode of energy, renewable energy. Okay, so wind power plants rotates because of the wind. And then that generates electricity using, again, the dynamo of Faraday's dynamo. And that electricity comes to your home. So there are various other methods, but I'm just taking 3 methods here. So you can actually list down a few more methods and trace the energy chain for the remaining ones. Now let's trace the energy chain for these 3 methods of electricity. So let's take the coal. Coal. So where does the coal come from? Coal come from thermal power plant actually requires coal. Coal comes from where? From the coal mines. Coal comes from the coal mines. So who put them there? Who put the coal there? The coal was put there, not just put there. The coal is there because of they are also fossil fuels. They are basically there because of the dead and decayed animals. So dead and decayed animals created that, plants and animals created that coal. And these animals and plants got energy from plants, and plants got energy from sun. So finally we can clearly say that sun again here So we traced the coal path and thermal path, and we saw that it is again sun. Now let us trace the path of the wind turbines. So wind turbines actually, who causes the wind? So we have to see that, who causes the wind. So what happens is when the sun heats up the Earth's surface gets heated up very fast before the actual atmosphere gets heated up because of the specific heat of Earth. Okay, so once that happens, the air near the Earth's surface gets heated up first, and because the hot air is actually lighter, the hot air climbs up like that, and once the hot air climbs up, what happens? In that place cold air comes down, and this movement of the hot air and cold air continuously like this sets up something called as convection current, and that causes wind. This is one of the reasons of the wind. Okay, we can trace other reasons too. This is one of the reasons. So once the wind comes from that goes into our wind turbines, and again Faraday's dynamo, and then we get energy. So who causes wind? Sun causes wind, and hence we know there again it is sun. Okay, so let us see the hydroelectric power. Here at least we can avoid sun maybe. See, it is water coming down from there, and we will put a water turbine, and that is basically going to give us electricity. So it is water which is giving us electricity here. So we think. So if we go a little further and ask a question, yes, who actually puts back the water onto the top of the waterfalls? Who puts back? So now the question gets interesting. So it is the sun who evaporates the sea water, and once he evaporates the sea water, then the clouds get formed and it starts raining, and that rain puts water on the top of the waterfalls. So then again here sun is the main reason the water actually keeps falling down. So sun is responsible for hydroelectricity too. So we traced everywhere up to sun. Now who lights up our home during days and nights? So the answer is very clear. We will agree that it is sun. But we know that sun is powered by nuclear fusion, which is called hydrogen bombs. So we say our home or your home is powered by hydrogen bombs. So the question is where these hydrogen bombs are getting energy from. So that is another story. So if we look at the Big Bang theory, it's another theory which talks about how our universe was actually formed and how it took birth. That gives an idea of how hydrogen bombs are actually getting energy from. But that is for another day. So we shall discuss about how all the energy which comes in the whole universe is because of the Big Bang on another day. So today, what we will do, we will end the session with 2 questions, and you can actually try out constructing energy chains for 2 scenarios. One is construct the energy chain of an arrow shot from a bow. You take a bow and shoot an arrow, and whatever the arrow flies out of your bow. So how is the energy that is going to the arrow? Where does it come from? So create an energy chain for that. Similarly, construct the energy chain of wooden log floating up from the bottom of the sea. So you take a wooden log and keep it in the bottom of the sea. It naturally comes up. So there is a motion. So energy is required for that motion. So where is this energy coming from? So think about it and construct an energy chain. So happy constructing the energy chains. Meet you next time. Bye.